today in Algebra 2, we're going to look at the second half of section 5.3, which dealt with graphing radical functions. So today we're going to start with rewriting radical functions to identify the transformations. So it says rewrite the following radical functions to identify their transformations from the parent graph using properties of radicals. So number one, g of x equals the square root of 9x. So what can I do? I can separate the 9 and the x. So this is really the same thing as the square root of 9 times the square root of x. The square root of 9 I know is 3. Okay, so I can get g of x is equal to 3 square roots of x. Now I can very easily identify the transformation of this function from its parent, the square root of x. That 3 out in front, that's like my a. So this tells me that I had a vertical stretch by a factor of 3. So that one was kind of nice and easy. So let's look at another one. Number 2, the square root of 4x plus 16, all of that plus 7. So here underneath my radical, I have 4x plus 16. What do they have in common? So I could factor a 4 out of that, and then I get x plus 4, all of that plus 7. So now again, this is like the square root of 4 times the square root of x plus 4, all of that plus 7. So I could say h of x is equal to the square root of 4, that's 2, square root of x plus 4, all of that plus 7. Now this is very easy to identify what my transformations are. I have that 2 out front, so again, I have a vertical stretch. This time, times by a factor of 2, x plus 4, so that means I go left 4, and plus 7 means I go up 7. Number 3, m of x equals the square root of 7x minus 3.5, all of that minus 10. Again, I can factor in underneath, so 7x minus 3.5. I want to pull whatever that number is in front of x, so I'm going to factor 7 out. And so I know I'm going to get x minus. So remember, when you're factoring, you're just dividing. So 3.5 divided by 7 leaves me with 1/2. All of that minus 10. So this is really the square root of 7 times the square root of x minus 1/2, all of that minus 10. So my function m of x equals the square root of 7 times the square root of x minus 1/2, all of that minus 10. So my transformations, so I have the square root of 7. So square root of 7, again, that's bigger than 1, right? So again, I have a vertical stretch by the square root of 7. X minus 1/2 tells me I go right 1/2. Minus 10 tells me I go down 10. Okay. Number 4. f of x equals negative 2 times the square root of 12x, all of that plus 4. So right now, I have negative 2 square roots of 12 times the square root of x, all of that plus 4. I can do factor tree on 12, right? That's 4 and 3, or 2 and 2. So I know I have a pair of 2's that come out. So really, this is 2 times negative 2. I have a negative 4. I have a square root of 3 left, times the square root of x, all of that plus 4. So I can say that that's what f of x is equal to. That negative tells me that it's a reflection. I have a reflection. The square root of 3, right? So I have 4 square roots of 3. This is going to compress it. Okay, inside the radical is a horizontal compression. Okay. So the square root of 3. So I would get horizontal compression. Or remember, I could write this as well as a vertical stretch, right? Horizontal compression, okay, or vertical stretch. Remember that they are the same things here. I have a factor of 4 square roots of 3, and then the plus 4 goes up 4. So on any of these up here, I could have also, instead of saying vertical stretch, I could have said that it was a horizontal compression. Okay? All right, so that's rewriting the radical functions to identify transformations. Okay? So the last thing that we want to talk about is how we write the equation of a transformation. So now they give us the graph, and we have to identify, okay, what transformations happened. So number one, this is the graph that they give to me. The only two that we're going to be looking at are square roots and cube roots. So it's easy to identify that this is a cube root, right? So I know that my parent, I know that the parent here was the cube root of x. Okay? So if I know that that was my parent, let's think about that one's xy table. So -8, -1, 0, 1, and 8 would have given me -2, -1, 0, 1, and 2. Right? So now let's just do the new xy table, the new one that we've got. We see we've got a 0, 0. I have a -1, -2, and a 1, 2. Okay? I see my x's didn't change, right? So I didn't move left or right any, and I didn't move up or down any. What happened were my y values changed. So what did y get multiplied by? Well, what do I have to multiply 1 by to get a 2? 2, right? So this was a 2y. My x's stayed the same. Okay. So I see that the equation, I could say f of x equals 2 times the cubed root of x. Okay. So this had a vertical stretch by a factor of 2. Okay. Let's look at the next one. Number 2, again, very easily, I see there's no sideways s, so I know that this is coming from the parent would have been the square root of x. And I can look at what are my original parent values. So 0, 1, 4, 9, 0, 1, 2, 3. Let's write down what do I have. I have -5, -4 is my very first one now. -1, -2, 4, -1. So I very easily see that my x's moved left 5, right? They were x minus 5. What happened to my y's? Okay, went from 0 down to -4. So I would get there by subtracting 4. 1 minus 4, or sorry, 2 minus 4 would have put me at the -2, right? So if I did 4 minus 5, I'd get -1. 2 minus 4 gets me -2. So all of my y's went down 4. So this equation, I could say f of x is equal to the square root of x plus 5, remember, because it comes out opposite, all of that minus 4. So I went left 5, down 4. There were no stretches or compressions. Okay, let's look at number 3. Again, very easy to identify that this is a cubic to begin with. So my parent, again, -8, -1, 0, 1, and 8. You know, these are the numbers I started out with. All right, so we want to identify the xy table, the new function that we have. So xy, so let's see, my 0, 0, my turning point is now at 0, -2. Then I have, it looks like a 1 and a 1/2, a 2 and a 0. So I noticed right off the bat that it went down 2. Right? It did not, the graph did not move any left or right, but notice that this 8 went to a 2. So it did not go no left or right, but x changed, right? So therefore, that means there is a change underneath the radical. So this is going to be a horizontal compression, right? So if I'm looking at horizontal compression, then I'm going to take the square root of 8, ended up being, or sorry, this is really the cube root of 8, ended up being the cube root of b times 2. Right? What do I have to multiply 2 by to get that 8? b was 4. So my function here would be f of x equals the cube root of 4x underneath my radical. Erase some of that radical. All of that minus 2. All right, last thing that we want to talk about is how to interpret a radical function model. Okay? So the word problem, it says looking out to sea, the visibility in miles from a certain spot on a cliff can be calculated using the function d of x equals the square root of 1.5x, where x is the height in feet above sea level. Taylor walks through elevations ranging from 5 feet to 40 feet above sea level. What are the minimum and maximum distances that she can see? Well, if she walks 5 feet, plug 5 in, so let's find d of 5 equal the square root of 1.5 times 5. So this is going to be the square root of 7.5. Plug that into our calculator. We find that this is approximately 2.74 miles. So the minimum is approximately 2.74 miles that she can see. And then she walks to 40 feet above sea level, so do d of 40. Plug 40 in. 1.5 times 40 is equal to the square root of 60. Again, plug that in. So that's approximately 7.75 miles. So the minimum distance that she could see would be about 2.74 miles. The maximum distance that she could see, about 7.75 miles. All right, number 2 uses the same function as in number 1. Suppose Taylor's brother walks through elevations ranging from 8 feet to 48 feet. What are the minimum and maximum distances that he can see? So we're going to find d of 8, the square root of 1.5 times 8, which is the square root of 12, which is approximately 3.46 miles. So the minimum he can see is 3.6 miles. Plug in 48, so the square root of 1.5 times 48 is the square root of 72, which is approximately 8.49 miles. So then the maximum that he would be able to see is about 8.49 miles. Okay, so that wraps up section 5.3. Your homework tonight is Envision. Okay, so log into Envision. You will do all of the problems. It will cover 5.3 day 1 and 5.3 day 2. So you'll see some of the stuff that we did yesterday, graphing again. Make sure that you take a screenshot of your score, upload that in Canvas. And then tomorrow we will look at test reviews together and take our tests over 5.1 to 5.3.